Yeah. So I could introduce myself or anybody who wasn't here earlier. So my name is Boston. I'm a software engineer at Bayesian down in St. George. We do print management and workflow automation. There's cool stuff. We do actually have an associate level role opening up soon. So if someone's interested, come and talk to me. We could chat about it. It'd be really awesome. So this lightning talk is very back. It's going to be kind of silly and very interactive. So like she said, it's Spooky Go. For a couple of years, I've been compiling a list of Go things that when you read the code, you think it's going to do one thing, because Go is typically very simple, and then it does what you don't think it's going to do. And so let's get into it and experience that 5 or 6 examples here to go through for this. So the first one is JSON encoding. So we've all used JSON before. I'm sure. Here we have this main function. We have a anonymous struct that we populate. It has 2 properties in there. It's a time.time and then a string. We get the current time, and then we have start. We create an encoder to standard out and encode it. So what are the thoughts that's going to be printed out from this? Or is it going to panic, or is it going to error, or what? Does anybody have any guesses? Yeah.
It's not going to show anything because your structs aren't public. No, one of them is public.
A good guess, though, is it wouldn't show anything because they're not public. Yeah.
Yeah, sorry, that was what I was going to say. They're not exported, so they won't be in the.
Time is important.
It's embedded, yeah, but it's not gonna. It's all got private fields.
Well, when I click run, what's gonna be the output?
Oh,
I think it's a struct with time.
Yeah.
JSON object with just time.
Yeah.
That's my guess.
All right, let's run it.
3239.
We got the time. So let's why, right? So here we have, it's an anonymous struct, but time.time is embedded. We didn't give it a property, so it's embedded. And then embedding carries methods, and time.time has a method of Marshall JSON. So when it went through the JSON encoding, it called the Marshall JSON for it and got the result because it's just embedded and not given to a property.
1 second. I think I must have.
Okay.
Sorry, I wanted to make sure I could see you on your. There you go.
Okay.
You're good.
Thank you.
I apologize.
No worries. Does anybody have questions about this one? Does that make sense? Kind of a silly one. All right, the next one is method expressions. So we have a point struct here that has an x, y, and then we have an add method that returns x plus x and y plus y for the added point value. So this is the easy one. What's going to come out on this? What do you think we'll print?
1 1
Adding 1 1 and 2 2.
1 1.
Guess is 1 1. We get 3 3, so we're adding the 2 and 1 to 2 again, right? Now let's look at the same example. All the code's the same except for this last one, where instead of taking p.add, we're instead doing point right off the type .add with p and q. Is this going to run? If it does, what's it going to print?
That's all it wants.
What's the guess?
There's no point.
I think it's going to panic.
I think it's going to panic. Some people are thinking 0 0. All right, let's run it. It's the same. This is valid Go. So it turns out this is called a method expression. Because this is not a receiver type, you can call it right off of the type on there, and the first value goes in is that receiver. So because it's not a pointer receiver, that's what I meant to say. So that's a fun, tricky one. All right, this is the hardest one, I think. Here we have a slice of ints. We populate it with a single int called a. We append the a, so now we have 2 elements, both of them 0. We create a copy of the slice with b, and then we append 1 to a, and so we get 0 0 1, and then we append 1 to b, we get 0 0 2. If I print the third element of a, what number will it be?
2.
Two.
Set out. Give me two.
So,
All right, let's see. It is 1 because A is 001, right? So we set A to 001, and so it's 1. So now let's look at this one. So the only change in this code is that we're going to start with 2 elements in our slice. Everything else is the same other than there's an extra element there. So when we append to A, we're now at 4 elements with the 1. And when we append to B, we're now at 4 elements for B. So now let's print the 4th index in there, so that index 3. What's going to be printed out this time?
Now it's a two.
I like this.
It's going to be still 1. Some people are saying 2. There's really only 2 options here, so it's one of those 2. And it is 2. Does anybody know why?
Yeah, wait. Is it because this?
so you can do it. Send it.
I was gonna say, is it because on the first one the slice gets reallocated on the append?
Yeah, so slices are windows to an array.
Oh, good call.
In the first one, our array is just one size, and Go just picked it as one size, right? And then when we created B, it was just a window on that one. And then when we appended the A, it made that underline array bigger here. And then B created a new underline array that it appended to. But in this case, since B is just a window on that slice or on that array underneath, when we start with 2, it already made it big enough to hold all 4 of these indexes. And so when we appended to A, we added 1 to the 4th index on the array. And then we appended to B, it replaced that 4th index with 2 on the underline array. What?
There's the ownership shared between the two.
Yeah, there's shared ownership there. So you gotta be careful. All right, this one is not interactive, but this is kind of a cool one. This is a rewrite of from context. I'm sure many people here have used context using some spooky Go features. So it's put it into 2 lines, but you can think of this as all one line of a generic version of this type. What we have in here is, we talked about method expressions earlier. So instead of doing ctx.value, we can work right off the type and then pass it in as the first value. We can put in an anonymous 0-sized struct, which is kind of a fun type of struct, takes no memory and is anonymous. And then we could also put this on the same line because Go is a C-like language. We can put it on the same line with just a semicolon. So you can get a little wild. Then the last one I have here is the fact that arrays can behave like maps, which is kind of a silly way. So we have this array of small primes, and it's going to be bool for each number up to 40 we have here. So we could say, okay, the first index is false, false, 3 would be true, right? False, true. Then we could say, okay, 7's true, 11's true, 13's true, 17's true. Then we could go back to not putting the number if we wanted to and just say that 18 is false and 19 is true. This is like the cleverest code you could write. I would recommend never doing it. So that's some spooky Go for you. I hope you learned something that you probably won't use, but it's
What does it fill the rest of the array for those values? Are they just nil or?
yeah, they're no. So they're false.
Oh, gotcha.
One more question.
Oh, yeah.
Share out your slides like on the Slack.
Yeah, for sure.
On your JSON example, if you did export the S, I think you'd still just get the time. Yeah, okay.